You know that feeling, right? You're scrolling online, maybe checking out a new product or reading an article,
Hmm.
and almost before you can even think, the perfect recommendation just pops up.
Yeah, it's almost spooky sometimes.
It is. It feels so seamless, almost clairvoyant, you know?
Hmm.
We all experience it, but honestly, very few of us truly get what's happening, like the engineering behind the scenes.
Right.
Okay,
Right.
let's unpack this because, I mean, in our digital world now, everything feels so custom-made. Getting that real-time relevant content isn't just a nice to have anymore.
No, it's definitely
It's
not.
pretty much what we expect now, isn't it? It's like the baseline for engagement.
Absolutely. And the architecture we're diving into today, it's designed precisely for that. It's a scalable, end-to-end solution.
End to end, okay.
Yeah, built to instantly capture what users are doing, process those events as they happen, and then, this is the key part, provide truly dynamic, personalized recommendations with like minimal latency. What's really transformative, I think, is the ability for businesses to react immediately, like right when you do something.
That instantaneous reaction,
Yeah.
yeah, that's the real game changer. So our mission today really is to explore the blueprint laid out in this document, from click to recommendation, real-time streaming architecture on Databricks.
Mm-hmm.
We're going to pull back the curtain, look at the key tech powering this whole thing. We're talking Apache Kafka for the streaming,
A backbone, yeah.
Apache Spark, structured streaming for the heavy lifting, the processing,
Robust process.
Delta Lake for keeping the data solid, and Databricks SQL for looking at it in real time. Here's where it gets really interesting.
Okay, so from a high level, picture this. The system is built to just seamlessly pull in user activity from, well, pretty much anywhere.
Like web, mobile?
Web, mobile apps,
Wow.
IoT devices, yeah, even data scattered across different clouds.
Okay.
And as soon as it comes in, this real-time data goes through some really critical processing. Things like schema validation.
Making sure it fits the pattern.
Exactly. Deduplication, getting rid of doubles, and just general quality checks. Got to make sure it's accurate.
Makes sense.
And this clean data, it then intelligently builds and updates user profiles, like on the fly,
Continuous.
continuously. And that feeds this adaptive personalization engine. It uses collaborative filtering, specifically ALS machine learning models.
Okay, ALS, we'll get into those.
We will. And, for making sure it's reliable, like enterprise grade stuff.
Right, they can't just fall over.
No way. So it's got robust features like checkpointing, monitoring listeners to see what's happening, error handling, and it's all orchestrated. Databricks Workflows handle that, making sure it scales and can handle failures.
All right, now that we've got that bird's eye view,
Yeah.
let's start peeling back the layers. We need to understand how all these pieces actually dance together to make the magic happen.
Okay.
Every real-time system, it needs a solid starting point, right?
Yeah.
Like a foundation for all the heavy lifting. And here, that starts with the Spark session.
Indeed, yeah. Think of the Spark session as like the engine room. Okay. It's the distributed processing environment. It lets this architecture handle just massive amounts of data and complex calculations spread across a whole cluster of machines.
Which you absolutely need for real-time scale.
Absolutely essential.
Okay, engine's running. Now, the critical starting point for the data flow itself, that's the Kafka stream for
Okay.
user activity, right? Why Kafka? What makes it the right choice here to kick off this high-speed pipeline?
Well, Kafka isn't just fast, though it is fast. It's designed, this distributed partitioned log, that gives you incredible durability and fault tolerance.
Ah, okay, so it doesn't lose stuff.
Exactly. It's essential for making sure every single user interaction, every click, view, search, whatever, gets captured, no loss. Even if traffic suddenly spikes like crazy,
Right.
it acts as that high throughput, fault-tolerant backbone,
Yeah.
which is crucial for recommendations because if you miss even a few events, it can kind of skew the model's understanding of what the user actually likes.
Okay, so the data's rushing in on the solid Kafka backbone. But raw data,
Mhm.
it can be messy, right?
Oh, definitely.
So what's the first critical step to make sure this, like, fire hose of information is actually usable, reliable for everything downstream?
Right. That's where schema validation steps in. Think of it as the frontline defense for data quality.
The bouncer at the door?
Kind of, yeah. It ensures every single incoming event sticks to a precise data contract defined structure.
Okay.
And it's not just basic formatting. It's about stopping errors from cascading downstream later by catching bad or incomplete data right at the start, at ingestion.
Gotcha.
And then right after that, you have robust data quality checks and deduplication. And again, it's not just about removing duplicates. It's ensuring you're working with the cleanest, most reliable data possible. That's just paramount for good recommendations.
Okay, critical cleanup done.
Yeah.
We now have this stream of validated, deduplicated user events. Where does this clean data land, and what makes that storage layer the right fit for these continuous updates you mentioned in a real-time system?
That cleaned event data, it gets streamed immediately into Delta Lake.
Delta Lake, okay.
Now, Delta Lake, it brings the reliability you'd expect from, say, a traditional data warehouse.
Right.
Things like ACID transactions.
The atomicity, consistency.
Exactly, all that good stuff. And schema enforcement, too. But it brings that to the flexibility of a data lake.
Best of both worlds.
Kind of, yeah. It means you can continuously update your user profiles and maybe product trends in real time without worrying about corrupt reads or inconsistent data halfway through an update.
Okay, explain ACID a bit more, the atomic part.
Sure. Atomic transactions basically mean that a set of changes either all succeed completely or they all fail entirely. Nothing gets left half done.
Prevents those partial, corrupt updates.
Exactly. And Delta also has versioning, which lets you time travel back to see previous states of your data. Super useful for auditing or debugging if something looks off.
Which must happen in a system with data flowing constantly.
Oh yeah, both are vital.
So you highlighted that core benefit. But this isn't just about storing the raw clicks and views, is it? The system builds those real-time user profiles you mentioned directly from this cleaned data.
Precisely. Yeah, this is where you really shift from looking at users in static groups or segments to understanding individual preferences moment by moment.
Wow.
So based on those clean events, the system groups user activity over, say, defined time windows, maybe every 10 minutes, maybe shorter.
Okay.
And it counts their interactions with different products within that window. These continuously updated user profiles, they're also stored in Delta Lake.
Making them instantly available.
Instantly available for the personalization engine. It's like the system is constantly taking your digital pulse, understanding what you're into as it changes.
Okay, so we've got individual user profiles being built dynamically. What about the bigger picture, like broader trends? Does the system capture that too?
Yep, it does that concurrently.
Yep.
While it's building those individual profiles, it's also identifying real-time trending products.
How does it do that?
It's actually pretty straightforward. It just counts the overall interactions for each product and orders them by popularity.
Ah, simple count.
Simple count, yeah. But it gives you a dynamic view of what's hot across the entire user base right now, which complements the personalized recommendations nicely.
And that trend data also goes into Delta Lake.
Also continuously updated in Delta Lake, yep. Ready to be queried.
Okay, we've laid some serious groundwork here. Robust data pipelines, clean data, dynamic user profiles, trend data. But the real breakthrough, the thing that makes it all worthwhile, is how the machine learning stitches it together.
Right.
To deliver those really personalized recommendations, how does that piece of the puzzle actually work?
Yeah, this is where the ML comes in. Specifically, they use a pre-trained ALS model that's alternating least squares. It's a type of collaborative filtering.
Collaborative filter, like people who bought this also bought.
Sort of, but more sophisticated. Think of it like this. If you, user A, and someone else, user B, have shown similar tastes, maybe you've both clicked on products X, Y, and Z, and then you, user A, interact with a new product Q. The ALS model can infer that user B might also like product Q, even if they've never seen it before.
Finding hidden connections.
Exactly. It's about finding those hidden connections in the collective behavior to personalize for individuals. It lets businesses kind of anticipate user needs, maybe even before they clearly express them.
And pre-trained means it's ready to go.
Pre-trained means the model's already learned general patterns and is ready to start making predictions quickly. It efficiently analyzes these complex user behavior patterns to generate specific, like, top-end recommendations, the top 5 or top 10 items for each individual user in real time.
And where do those recommendations go?
Those highly tailored recommendations, they get written right back into Delta Lake, making them instantly queryable.
So, wow, we've literally gone from a single click through all this real-time processing, intelligent profiling, ML magic, generating these very specific predictive recommendations. What's the ultimate goal here? What's the payoff for all this tech?
Well, the ultimate goal is really about providing immediate, actionable insights and driving real business value.
Okay.
So the architecture includes integration with Databricks SQL Dashboards.
Ah, visualization.
Exactly. This allows for live queries directly on those generated recommendations in Delta Lake. So businesses can see, like right now, what products are being recommended, who they're being recommended to. They can even analyze emerging trends from the recommendations themselves.
So it's not just data locked away, it's instantly usable.
It's instant visualization for rapid decision-making. That's the idea.
And this whole thing is a real-time streaming system, right? Designed to run continuously. How does it make sure everything keeps running smoothly, reliably? What happens if something, breaks?
Yeah, good question. That's where the robust reliability features are absolutely key. The architecture uses streaming listeners for monitoring.
What do they do?
They actively track the progress of the streaming queries. It gives operators real-time visibility into the health of the pipeline, like, is it keeping up? Are there errors? It also uses enhanced checkpointing for each stream. Think of checkpointing like taking regular snapshots of where the stream is in its processing.
Bookmarks.
Yeah, like bookmarks. So if the system crashes or needs restarting, it knows exactly where to pick up from. No lost data, no reprocessing stuff it already handled.
Crucial.
Super crucial. And of course, robust error handling is built in throughout. Then this entire kind of intricate process, it's all orchestrated using Databricks Workflows.
So Workflows manages all the jobs.
Yeah, it schedules them, manages dependencies, handles retries if something fails. It ensures the whole thing runs scalably and is fault tolerant, even across different cloud environments.
Okay, bringing this all together then.
Sure.
What does this really sophisticated architecture truly mean? We've taken quite a journey here from just a simple click to understanding this complex, real-time recommendation engine. So what does this all mean?
Yeah, if we connect this back to the bigger picture,
Yeah.
what we've really explored here is effectively it's a blueprint for next generation customer personalization.
A blueprint.
It really enables brands to react instantly to what users are doing, recommend the right thing at exactly the right time, and at the end of the day, drive customer engagement and satisfaction.
Right.
This architecture, it isn't just about the tech, the scalability. It positions businesses to offer really meaningful, context-aware experiences, but at a massive scale that fundamentally enhances both the business value and, importantly, the user experience because you're truly understanding and anticipating their needs.
And that definitely leads to a fascinating thought for you, the listener, to maybe chew on. With this kind of powerful, pervasive, real-time personalization becoming, well, kind of the norm, how might our own expectations for digital experiences keep evolving in the next few years?
Nah.
What does it really mean when pretty much every interaction you have could lead to an immediate tailored response? And how might that fundamentally reshape the products and services we use every single day? Something to think about.